Good morning. For any of you struggling with the graphs, I'm doing an extra video to try and help out. So your task is, if I show the screen for a sec, is to draw graph A and then draw graph B. So what I'll do is I'll talk you through graph A and help you draw it, and then hopefully you can have a go at graph B. So you'll need that up in front of you because you will need to draw this because you'll still need to do the comparison afterwards. So as I said, with a hydrograph, you do have your normal y and your x-axis, but your y-axis is a little bit weird because you have a mini axis in there as well. So what we'll do is we'll start off with the rainfall on the left-hand side. And in terms of when you plot graphs like this, you need to decide your own axes. So for this one, obviously we've got time along the bottom, and we're doing for rainfall up to hour 6. But notice that for discharge, we're going up to hour 20. So on the bottom of your graph, obviously you're going to want 0 to 20. Sorry, the cat's walking across my screen, which is really helpful. But your rainfall's only actually going to go up to about 6 here. So we kind of just roughly plot. There's 10, there's hour 5, there's hour 15. And that will do for your axis along the bottom, your x-axis. And remember, should be nicely labelled. So we're looking at time, and in this case, we're doing time in hours. Then for your y-axis, notice on your tables here, we've got rainfall amount in millimetres, and it goes from 5 being the smallest to 52 being the biggest. So I would go 0 to 60 millimetres just to cover you for that 52. So down the side here, we're going to make a little axis, like a little tiny one over here, and it's going to go from 0 to 60. Again, it'd be much easier when you haven't got massive pens like this. So what we've got about 30 in the middle, so that'd be 40, 50, 10, 20. And that's our rainfall in millimetres. Rainfall millimetres. So what we'll do is we'll plot the rainfall first as our little bar graph, and then we'll move on to the discharge. So for your hour 1 to 2 down here, your first bar is 5, so it's going to be a really tiny little bar down there for 5. Then hour 2 to 3, it goes to 15, so that's 10, 15 will be there. Again, I'm not doing this accurately, you can do it more accurately than me. Hour 3 to 4 goes up to 52, so our third bar is going to be up here somewhere, isn't it? Like that. Then we've got 40, so 40's there for our next one. And then our last one, hour 5 to 6 is, again, I haven't done this very accurately at all, have I? Is 23, so it's about there-ish. Okay, so along your bottom here, you'd obviously have 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5. And you can fill that bit in. So that's your bar graph. The simple bar graph showing your rainfall in the left-hand corner, and needs to be squished down the bottom. When we start putting our discharge in and it starts doing a line graph, it's just easier if you've got that tucked down out of the way. So the next bit we've got, if we go back to the screen, is we're now going to plot on the right hand side that table. So time 0 to 20 hours, and discharge is going to go from 5 at the smallest to, what's the biggest? 110. So again, our axis down the side should be 0 to 110. And we're going to do it on this main axis now. So in fact, just to make it easily dividable, I'm going to go up to 120. So halfway is going to be 60. Again, halfway in between there is 60, 80, 100. There we go. And we could put the divisions down here. That's going to be 40, isn't it? You can put your squeeze yours in a bit better. 20 down there. And that is our discharge. And that's in cumex, which again, I'll remind you, stands for cubic meters per second. That's what we're measuring the discharge in. It's essentially is how much water is flowing through whatever gauging station you've got at a certain speed. It's how fast and how much water there is. So we're now going to plot a line graph for this one. So the first one you have to plot, if you look at time, it says 0 hours. Our discharge is 5 cumecs. So your first point is going to be down here somewhere, put a little cross. At 2 hours, we know where 2 hours is. It is 8 cumecs, so only a tiny bit higher. At 4 hours, it's 15 cumecs, going to be up here somewhere. 6 hours, we go to 50. So we suddenly start to jump up. 8 hours, we go to 85. 10 hours, we go to 110. So we've got our peak. Then at 12 hours, we go to, where are we, 90. 14, we go to 65, which is down there somewhere. 16 hours, we go to 45. 18 hours, we go all the way down to 20. 20 hours, we go down to 15. So we're kind of back almost to where we were before, aren't we, down here? Again, once you've got all your little crosses, all you need to do is just very roughly join them up like that. And there we go. There is our hydrograph for graph A. And again, I mentioned in the video before, there's a few things you can take from this. So if you go from your peak rainfall to your peak discharge, that length of time there is what we call the lag time. That's how long it takes for the water from the rain to reach your river. So in this case, what was that? That was about hour 2 to 3. So we'll say hour 2 to hour 10. So our lag time is 8 hours, because it took 8 hours for most of the rainfall to get into our river and create our peak of our discharge. So I guess if you live nearby, you know that in the middle of that storm, you've got 8 hours until you need to put sandbags outside your door to stop the water coming under. So that's why that's really, really useful to know. So graph A looks what we call quite flashy, in that we get rainfall and then suddenly, only a few hours later really, we suddenly get a big peak. That means that lots of rainfall is very quickly getting to your river. If we had a line that went down like this, for example, it doesn't go up very high, and in fact let's change it a little bit. Let's make it peak over here, and the peak is much further along than this one. It obviously takes a lot longer for the water to get into a river as well. So graph B, I'll give you a hint now, should look very different to this one. It should be much lower, and I think your peak then occurs later on as well. So have a go at drawing graph B. Once you've got them both, you'll be able to compare them. And then I want you to use the graph on the graphs on slide 9. Again, I'll refer you back to the screen there if I can get it to stay. So you'll notice what you then need to do is you need to go and say which one you think refers to which graph, A or B. So when you're having a look, you want to say, okay, is A or B the larger or the smaller drainage basin? And that's the area that your water falls in near your river. So if you've got a really big peak, then it's going to be a large drainage basin. Now we've already said on graph A, we've got a large peak. So we're expecting your graph B to have a smaller peak and therefore be a smaller drainage basin. I can't remember what I did now, but I'm pretty sure that's the case. Again, go to vegetation. If you've got bare soil, your water will very quickly get into the river. So you'll have a very flashy river with a very steep rising limb. So again, this one's got quite a steep rising limb. So we're assuming this one's probably got the bare vegetation and graph B's probably got the forest. That's all you need to do. Draw the two graphs and then decide which one refers to each one of these 4 things. I hope that helps. Sorry, cats and children interrupting. Have a go. Any other questions, or if you need any more support, give me a shout.